We're in the section, this is section 3.5, the harder ones. So we're working on the harder ones now. And the 3.5 harder ones. So what I want to do before we dive into this question, let me just remind you of what they assume you already know, but I know from years of teaching that that is not the case, and it's just hard to remember all this stuff, from algebra. They assume you already know. Let me just change to x. I just dropped the sign. I'll come back to it, but I want to first remind you, how do you solve just like if that was just x? We'll get to the sign part at the end. That actually won't be the hard part. The sign will actually be easy. The hard part will be just dealing with everything that leads up to the sign. So what if somebody gave you this question? Would you know how to solve that? It's a prerequisite to the course, but I know, it's in algebra, and algebra is a prerequisite to the course. I wish everybody knew it, and I could just go, yeah, you know how to do this, boom, 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 and we'd have plenty of time to do everything. But I know the reality is 99% of you can't solve that right now. It's been a really long time, or your algebra experience was less than perfect. And so we definitely need to review that. I'm assuming that none of you really can solve that right now. Anybody remember anything from your algebra days about how you solve x squared? Benjamin, what do you remember? Were they good days? I'm just kidding. You guys, not too bad. So what do you do?
0.
Yeah, right. So when you have an x squared equation, that's right. That's the first step. So I knew you would know, Benjamin. When you have x squared with an equal sign, step number 1, you get a 0. That's right. You want to get a 0 on one side first off. So when you have x squared, now I'm going to do the whole thing with x, and then I'm going to go back and say, all right, now let's do the same thing with sine. I just want to first make sure you're solid on what you would do if it was x. It's basically the same thing with sine. So first step, get a 0. So that means you bring this 1 over, or subtract 1 from both sides. Same thing. Whatever. And you get 2x squared plus x minus 1 equals 0. That's the first thing you do when you see x squared with an equal sign. So I'm giving you the steps, reminding you of the steps that you take when you've got an x squared with an equal sign. Step 1 is you get a 0. What do you do next? You could do the quadratic. I'm going to avoid it because it's kind of hard. There's another way. What? I can factor. Exactly. Yeah, you guys are kind of remembering some of this? Yeah, next you factor. Now, what do I mean factor? Well, factor is, there's two ways to factor. First, one way is you ask, is there a GCF, which means anything in common. That's what that means. What's in common? Like, do they all have an x? No, that 1 doesn't have an x, and minus 1 doesn't. Because if they all had an x, I would put an x in the front with a parenthesis. But they don't. They don't all have an x. Is there like a number that goes into all of them? No, there's no number. So there's nothing in common. So I don't do that kind of factoring. What's the other kind? The other kind is the 2 parenthesis FOIL factoring. That's what I do on this one. So I'm going to do like 2 parentheses. Like this. And I'm going to say, what would multiply to be that? 2x squared plus x minus 1 equals 0. What would multiply to be that?
2 x's.
Yeah, so let's start going after it. To figure it out, you've got to remember the term FOIL. Remember FOIL from your algebra days? What does FOIL stand for?
First, outside, inner, last.
Yeah, first, outside, inner, last. First, outer, inner, last. And see how I write the O and the I in the middle? First, outer, inner, last. What is that talking about? Well, that means in each of these parentheses, there's a first item and a last item. A first item and a last item. Each of the parentheses are going to have 2 things in them. And we're going to make it so that if you FOILed out the parentheses, it would go back to 2x squared plus x minus 1. That's what we're looking for. What would multiply to go back? That's what we're trying to find. There's all kinds of ways, different techniques for doing this. I'm just going to show you one. If you already know one, great. Feel free to do that. Here we go. I'm just going to do FOIL. I'm just going to guess, in other words. Basically, that means I'm going to guess and check. That's basically what I'm going to do. So the first one in this parenthesis times the first one in that parenthesis makes 2x squared. That's what the F stands for. First and first makes me. First times first makes 2x squared. So what times what is 2x squared?
X times 2x.
Yeah, and you can do it in any order. You can put the 2x here and the regular x there, or vice versa. The order on the first two does not matter. Either way is fine. But, hear me on this, the order on the last two matters a lot. So the order in which you put the first two doesn't matter. But once they're set, they're kind of set in stone. And the ones in the back, it'll really matter. So put that down. 2x times x is 2x squared, right? Remember that? Remember when you multiply 2x and x? That makes 2x squared. It doesn't make 3x. When does 2x and x make 3x? When you're adding. We're not adding. We're not talking about adding right now. We're talking about times, right? Parentheses. This is multiply, right? So 2x times x, that makes 2x squared, doesn't it? The invisible 1 powers add to be squared, right? Okay. Now, jump to the L. We'll save the middle. We'll handle it last. Jump to the L. Last times last. The last one in this parenthesis times the last one in this parenthesis makes 1. What times what is 1? Don't worry about the negative. We'll do the plus and minus stuff later. Just think about 1 right now. 1 times what is 1? Well, 1. Yeah, there's not really a lot of choices there. 1 times 1 is 1. What else could we do? 1 times 1 is 1. Good so far? Now, is the middle right? Again, notice I have not put plus or minus, have I? I'm saving that. It's too much to worry about everything at once. I'm saving the plus and minus stuff. So, okay. So, what? How do you get the middle? What does this mean? Outer, inner. What do we mean outer? What do we mean inner? We mean these two. Those are the two inner. And we mean these two. Those are the two outer. So, are we multiplying or adding here? Multiplying. Remember, everything's multiplying. Multiplying. So I'm saying 1 times x. What is that? Well, 1x. And 2x times 1. What is that? Well, 2x. And what do they want to make? The middle. What number's in the middle there? What number's really in the middle?
1x.
Plus 1x, huh? Visible 1 there. So how can now, for the first time, we will think about pluses and minuses. Notice I don't have any pluses or minuses anywhere, do I? Right? Does everybody, by the way, let's pause for a second. Does everybody see the steps I'm following? I really encourage you. Unless you're good at this. Unless when I first wrote it, you just snapped it out in your head, which maybe 2 or 3 of you did. Great, do your own thing. But otherwise, when I really encourage you to write the steps I'm writing. Write these arcs, write these arcs, write these things. Don't try to skip these steps. Don't try. The class I taught this morning, I was working through that, and I wrote some of these things, and then I'll spend some time. I'm going to try to meander around and try to help you a little bit because it's a hard stuff on the next problem. Anyway, but then I saw a lot of people not writing anything that I'd written, and which is fine if they can do it, but then not knowing how to do the problem either. I'm like, well, if you don't know what you're doing, then at least do what I did, right? So everybody with me, do what I'm doing, right? Don't skip it. Don't think I'm just going to skip it and do it all in my head. If you're that good, you would have done it. You wouldn't need any help, right? So if you didn't already know how to do this, then make sure you're writing what I'm writing. Okay, now, how can a 1x and a 2x make the middle plus 1? Now I'm going to think about signs. What can you do with a 1 and a 2? What pluses or minuses or whatever do they need to make plus 1 in the middle?
You have to subtract 1x from the 2x.
The bigger one takes his sign. There's the easy rule. The sign in the middle goes to the bigger player. 2 is bigger than 1, right? So the plus in the middle is going to go right there. And this one will be minus. 2, positive 2 minus 1 is positive 1, isn't it? Everybody good there? Clarence?
But if it was like a negative 2x, would that still be considered big? Or would it go to the 1 after since then?
No, I mean the 2 is bigger than 1.
Or just straightly 2?
Just straight number. Yeah, that was before there's any signs on it.
Right.
Just 2 is bigger than 1. So whoever's bigger gets the sign. So whatever sign, if there's a negative in the middle, the 2 will get the negative. If there's positive in the middle, the 2 will get the positive. Because he's the bigger. He's going to take the middle sign every time. Does that make sense? So the sign in the middle will always go to the bigger.
So we're adding or subtracting those two numbers to get it to 1x?
Yeah, exactly. Yeah, that's the only thing we have to subtract. Good point, Manveer.
So
Exactly.
the addition's going to be on the outer.
Yeah, so we'll backtrack it.
Gotcha.
Yeah, so let's backtrack it. Now, where's that sign go? Yeah, it goes right there on the minus. Yeah, exactly. What you're saying is right. And the plus goes back there because plus 1 times 2. Yep. And it's double. Let's double check. The only thing we haven't double checked is the sign. Negative is negative 1 times positive 1. Remember last times last to make last. We had the 1, but we didn't have the sign back then. Is negative 1 times positive 1, negative 1? Yeah, it is. It's all good. That's the right factorization. Meaning, if you went boom, boom, let's do it. I'll just do it real quick. You don't have to. Just watch me. 2x squared plus 2x, and boom, boom. Minus 1x minus 1. What is that in the middle? Plus 2x minus 1 plus 1x minus 1. See, that's the same as that, isn't it? When you check all those things, the first, outer, inner, last, and make sure they're all right, you're basically foiling without foiling. You're basically making sure it would work. Does that make sense? And if you want to just skip all that stuff and just foil it out to make sure it's right, that'll work too. Whatever.
Wait, I thought the positive goes on that parentheses.
So it's the plus or minus is only right here. It's what goes on right here. So the sign in the middle goes on the bigger of these two, which is the 2, and then the outer, notice, goes to the 2 outside guys. So he's going to go there. Right? That makes sense? Now, yeah. I don't want to confuse you by saying other things are false. Whereas the minus goes on these 2. Is that good for factoring? So I know a lot of people are rusty on factoring. I remember my own daughters a couple of years ago when I was teaching them, tutoring, helping them. They were taking Mr. Jameson for classes like this, and anyway, I would tutor them at the kitchen table, and I always remember them saying, I'd say, time to factor, gotta factor this, girls. And they would both go, Dad, we hate factoring. And I would always say, gotta learn to factor. Want to pass these math classes and get a college degree, you're gonna have to factor. And so it just takes practice. You gotta practice that factor. Is that good on that? Is that good there? Okay, so now there's one, we're not quite done. So that's the factoring step. That's step 2 there, and now step 3. What do we do now?
You solve each factor individually?
Yeah, that's right. Each one gets their own 0, huh? So you see how you have 2x minus 1 times, parentheses, x plus 1 equals 0. Now, so that's this was all step 2, the factoring. Now on step 3, each one separately gets their own 0. Like Bernadette was saying, each one you solve separately, they each get their own 0. Why? I don't want to do math like magic for you. I would not be serving you very well if I did that. It's not magic. That looks like magic though, right? I mean, the other steps make sense, right? The first step, we just subtracted 1 from both sides. That's fine. Same thing to both sides. And then we factored, meaning if you multiplied this out, it's the same as that, huh? So you know that's the same. But how about this? I mean, why is this okay? Why can you go from 1 equals 0 to 2 equals 0. How's that okay? How's that right or reasonable or logical or true? How can you go from 1 equals 0 to 2 equals 0? It didn't say they're both 0. It said them multiplied equals 0. Why does that mean each one's 0? Why is that okay? Y'all did that in algebra, right? You didn't just do what the teacher said without knowing why. That would be so boring and easy to forget, wouldn't it? And maybe that's how you feel about math. Maybe that's how you felt about math up to now. I hope a little bit of that is changing. I hope math is more interesting when you see there's reasons. To me, it's the difference between going, if you try to do math without any reasons for things. It's just steps, and you just memorize steps, and step 1, step 2, step 3, nobody knows why. We just do these steps. My goodness, that would be so. I would understand why people say math is boring and stupid and hard to remember all those millions of weird little steps here and there and everywhere. Oh my goodness, and so pointless. No wonder people feel that way. But you know what I feel like that's like? That's like me going to a concert and I'm deaf. And I'm looking around going, why is everybody tapping their foot and moving their head and people up on the stage, just doing something with some instrument? This is boring, stupid. How do they know when to tap their feet? Why is everybody doing it the same? Well, because there's music flowing, right? But that's what's happening. There's logic flowing through math. And if you're not dialed in with the logic, it's way less interesting and super hard because who knows what to do next? We don't know. There's just these random steps, and we don't know why anyone ever takes these steps. We just, teacher says them, we memorize them, we write them down. You know, that is boring and hard. No, there's a reason. What's the logical reason why this leads to that? What's the music there? What music is playing? Has the music never played for you? Back in your algebra days from here to here? Did the music go quiet from there to there? If I said, hey, I'm thinking, nobody? No, Benjamin, Bernadette, Clarence, nobody? If I said, hey, I'm thinking of two numbers in my head, and they multiply to be 0. Right? What if I really am? I'm thinking of two numbers in my head right now. And I'm timesing them, it's coming out 0. I'm timesing these two numbers, it's coming out 0. What does that mean about, what do you know? You know something, don't you, about my numbers. If I times in two numbers and it's coming out 0,
One of them's gotta be 0.
one of them's got to be 0. You all know that, huh?
Just one.
Right? You're not monkeys.
Both.
Monkeys can't think. I don't care what all the animal intelligence people want to say. It's ridiculous. They can do very simple things. They cannot, when they write a book, then I'll say animals can think, right? When they can't do math, they don't really, they reason very simply. But you all know that logic, that if two things multiply to be 0, either one of them could be 0. Couldn't it? Right? Because if the first one's 0, 0 times anything would be 0. And if the second one's 0, anything times 0 would be 0, right? So if I'm thinking of two numbers in my head, and they're timesing out to be 0, then that means either the first one could be 0 or the second one could be 0. You know that. That's true. Well, that's what this is saying. Are you hearing the music now a little bit? Do you see that this is, what the problem is you don't maybe naturally or normally look at this as one thing. But you realize that's one number. What do I mean 2x minus 1? Why am I calling that one number? Well, let me get that little thing out of the way there. I just don't know what x is currently. Remember, x is a variable. I'm going to try to find it at the end, but I don't know what it is right now. In other words, x could be something like, I don't know, maybe 3. If x is 3, then this is 2 times 3, 2 times x, 2 times 3, 6 minus 1. This is a big 5. This is a big 5. I don't know. I don't know what x is, but my point is, when I discover x later, I'll realize this is one number, won't it? Won't I? This is like, if x was 3, this is 2 times 3, 6 minus 1. This is a 5. And if x is 3, then this is a 4. Right? I don't know what x is, but I do want to look at this as one number, parentheses, times another number equaling 0. So do you see what it's saying? Do you hear the music? Something times something equals 0. What does that mean logically? Either the first one is 0 or the second one is 0. Huh. That's reasonable, isn't it? Either one could be 0 and they will times to be 0, won't they? Does that make sense on that? Ani?
Why don't we just use the quadratic formula?
You could totally do the quadratic formula. If you're comfortable with that and you're good with that, feel free.
Well, is it going to affect it? Like, is it going to be harder for this problem, like 2 sine?
No, it'll work. You could do it. You could do it. All right, so let's finish up. Now, how do you finish this up? You jump the 1 to the other side. 2x is 1, divide by 2, boom. Right, because I just added 1 to both sides, right? And then here, just subtract 1, so I'm just going to jump it to save time. So 1/2 and -1, we'd be done. If it was x. Now I'm going to go back and do the same thing for sine. But do you remember that? That's how you solve when you have x squared with an equal sign. You get a 0, you factor, and then each one equals 0, and you find your answers for x. And by the way, those really are the answers for it. Is that true? Oh yeah, it is true. I was looking up things. Is that right? Here, let me check one just to prove to you. Like if I don't want to put the fraction in. That's kind of a pain. But if I plugged in the -1 back up here, -1, -1. See how it works? It makes the equation true. 2 times -1 squared. What's -1 squared?
1.
1. 2 times 1, 2. Minus 1. Yeah, that's 1. Huh. See how -1 makes that equation true? 1/2 would work also. I don't want to mess with it anymore. Anyway, there's how you find answers. Okay, so now let's go back and do it for the real question, the sine. It's going to be, 90% of it's going to be this. Exactly the same thing. Except instead of an x, there's going to be a sine x. Instead of 2x, it's going to be 2 sine x. You know, it's going to be the same thing. So let's do it. So number 1, 2 sine squared x plus sine x equals 1. Okay, so when you see sine squared, it's like x squared. You think, oh yeah, okay, get a 0. So step 1. Step 1, get a 0. So I'm going to jump this 1 over. 2 sine squared plus sine x minus 1 equals 0. So step 1, get a 0. Step 2, factor, like with parentheses and all that. So we do the parentheses. And we're going to factor. Okay, so again, we think of FOIL. It's just going to be exactly the same, but I'll just go through it one more time. We're thinking FOIL. So front, or the first, or the front, whatever, times the front, to be the front. What times what makes 2 sine squared? Well, 2 sine times 1 sine, or regular sine, right? 2 sine times 1 sine is 2 sine squared. Is that good there? Right? 2 times 1 is 2, and sine times sine is sine squared. Huh? Is that good there? Just like with an x, same thing. And now, what do we do from here? Last times last to make last. What times what makes -1? Well, don't worry about the negative. Remember, I do the signs later. I leave the signs for now, and I just put the number 1 and 1. Is that making sense? Just the 1 and the 1. Don't put the negative. Don't put any signs at all. And now, where do I go from here? The middle, right? It's all about that middle. So let's get that middle. So the middle comes from oi, the O, the I, the 2 inner, the 2 outer. So I encourage you to draw those little arcs. So what is the 2 inner? What is 1? It's all multiply, isn't it? 1 times 1 sine x is just 1 sine x. And 2 sine x times 1 is 2 sine x. Okay, no pluses or minuses yet. Now's the time. Now, for the first time, we think about pluses or minuses. And how do we know whether to do plus or minus? What's the rule?
The big one takes the first sign. So
Yeah, the sign in the middle.
goes to the big.
Yeah, the reason I wouldn't call that the first sign is because that 2 really has a sign. It's a plus. So it's the middle sign. So the sign in the middle goes on the bigger. Always the bigger, huh? So that'd be the +2 minus 1. +2 minus 1 makes the middle plus. There's really a visible 1 there, huh? +1 in the middle. Is that good? How are we doing? That's making sense. Are we happy about this? Kind of painful, huh? Yeah.
So I'm just kind of confused on how would we decide on which way the negative or positive sign would go?
Oh, like once I have them here?
Yeah.
Yeah, good question. The one in the middle will always go to the left. This little one right here. This little, the 2 inner, the inner, that always goes on him right there. Because where does 1 sign come from? From these 2 multiplied. So it's got to be on this guy. So the minus has to go right there. So the sign you put right here always goes straight up. How about that? Straight up. And the bottom one goes to the back.
Because you think of it, the 2 signs that are in
Yeah.
the front are both positive.
Right.
So what
These are
you
positive, right.
multiply it by has to be negative.
Exactly. So you got to put the plus back there. The bottom one always goes to the back, like that. Is that good? It's just like what we did with the x's, now we're doing with sine. Okay, that's step 2, factor. And now, on to step 3 we go. What is step 3? Yeah, they each get their own 0, because if 2 things times to be 0, either one could be 0 to make them times and be 0, huh? So the first one equals 0, or the second one is 0. We good there? Okay, now, do you know how to finish those from there? What do we do from there? How are we doing? Going to move this 1 over. So we get 2 sine is positive 1, right? When things jump to the other side, they change their signs. That becomes positive 1. And then divide by 2. So where is the sign of half? Let's go to the unit circle. Our favorite thing in this class. Anyway, the biggest, most useful thing has been the unit circle. There it is. So where is this? So looking at usually there's two answers, right? Almost always there's two places. So look for two places where the sign is what? Sign is positive a half. Where is sign positive a half? Remember, it's cosine sine. There's one. Positive a half, pi over 6. Cosine sine, cosine sine, cosine sine, cosine sine, cosine sine. Oh, there it is, positive a half, 5 pi over 6. See those two places where sine is positive a half. Pi over 6 and 5 pi over 6. Good? Coming on back. So, pi over 6, 5 pi. Now, what about this one? Let's finish this one up. Move the 1 over -1. Where is, now go to the unit circle. Sine's alone there too. Go to the unit circle. Where is sine -1? Cosine sine, 3 pi over 2. Good there. 3 pi over 2. Sine is -1, isn't it? Right there. Sine -1. So that's 3 pi over 2. Those are our three. I just want you to type in all three answers. So the answer to the overall question, what they want you to type in is pi over 6, comma 5 pi over 6, comma 3 pi over 2. Any order, doesn't matter, just separate them with commas. And that's number one. It only took us 35 minutes. See, I'd like to give a half an hour to each of this. Is that good? Does that make sense? Questions I can answer? Right. Here we go. Here's number 2. So when we see sine squared, what are we supposed to do first? Remember those 3 steps I wrote out?
Get a 0.
First step, get a 0, right? So jump these things over to... Oh, and by the way, how do you know which way to jump things? It's good. You can do it either way, but it's going to be way easier for you to have the front term be positive, not negative. Am I making any sense? Am I going too quick? Maybe you don't even have it written down yet. Give you a second there. So notice I'm not going to take this guy and jump it over here. Why not? Because if I do, he's going to become -10 sine squared x. Why is that at the end of the world? Well, he's the front term. He's the sine squared. He's the leader. I don't want him being negative. I mean, there's no rule against it. It's okay, but it makes the factoring super hard. So don't do that. It'll be way easier for you to jump everything so that... So there's no rule as far as right side or left side. I'm not making a rule there. Don't hear me saying, you got to go to the left side or you got to go to the... No, either side's fine. I'm saying what'll be easiest is to jump everything to whichever side where the front guy will be positive. That just makes life easier. A lot easier for factoring. So I'm going to say, well, the front guy is positive on the left. I'm going to jump everybody to the left on this one. So 10 sine squared plus 22 sine plus 12 equals 0. Is that good? Step 1, get a 0. Making sense? Now this one has an extra wrinkle, a little curveball they're throwing at you. So I wanted to give you this one. This is worst case scenario. Step 2, what's step 2 supposed to be?
Factor.
Factor. We're going to factor now. When we factor, do you know what I wrote the 2 things here. Somewhere. Here. GCF first. Greatest common factor. I don't know if you remember that. Like, as you look at these 3,
So you need to simplify them.
is there something they all have in common? Yeah, 2 goes into all of them. We didn't have that in the last problem, right? See how 2 goes into 10 evenly, 2 goes into 22 evenly, and 2 goes into 12 evenly, doesn't it? So we got to do that. I'll show you what that means in a minute, but look back with me. See the last problem, how we didn't have that? We had 2, 1, and 1. I mean, nothing goes into them but 1. 1 goes into everything. We don't count 1. So see how there was no GCF on that one? There was nothing in common to all 3. But this one there is. So what do? You take out that 2 and you do 1 big parenthesis. And then on the next line, you'll go to the 2 parentheses. But first, you got to do the 1 big parenthesis, and the numbers are going to change. Remember this a little bit from algebra? Coming back a little bit? So what goes on the inside? Whatever works. In other words, 2 times what will be 10? 5. And then we just leave the sign squared. Plus 2 times what will be 22? 11 sign. 2 times what will be 12? 6. Is that good? Now, can you do the next step?
You still square it, even though you separated them? You put 5 signs square.
Right.
You still square it?
I just took out the 2 is all I did.
Took out what 2?
Not 2?
Yeah, but where'd you get it from?
I noticed that 2 goes into all of them.
Okay.
Yeah, so I'm noticing it's called the GCF. It's what they have in common. 2 is in common to all of them. They all divide evenly by 2. So I put the 2 in the front, and then I put inside whatever works. Does that make sense? Now, separate them, right, into the 2 parentheses. Do the FOIL. So let me give you a second. Try to do the FOIL factoring from there. So let's write FOIL F-O-I-L. Right? So this means first times first to make first. What times what makes 5 sine squared? That would be 5 sine times sine. So Jose, do you see there why I'm making them regular sine now and not sine squared anymore? Because sine times sine is sine squared, huh? On that. So is that good to there? Does everybody see that? So 5 sine times sine is 5 sine squared, huh? Good. Now we jump to the L. Last times last to make last. Save the middle, that's the hardest part. Last times last to be last. What times what makes 6? 1 times 6 or 2 times 3. How do you know which one? You guess. You guess and you check. Now I know that might sound like, really? Yeah. I mean, I know there's other fancy methods. I know about them all. I've seen them all. I'm telling you, if you're going higher, when you get higher in math, calc, nobody uses those other silly methods. Because they've done a million of these. They can just look at it and they can say it. So that's what everybody does. Guessing, checking is the way the more mature math people do it, because they can do it so fast because they've done 10 million of these. So that is the way. Don't mess around with those other methods. They're like training wheels. Ride the bike. Just guess and check and practice and practice and practice, and you'll get faster. You'll be able to just look at it. So what times what makes 6? Well, let me show you that 2 and 3 doesn't work. So write 2 and 3. That's a good first guess. Nothing wrong with it. How do I know it works or doesn't work? Whatever. It's all about the middle. How do you get the middle? The OI, which means inner, outer. Write those. Don't skip that. Draw those 2 arcs. And what is 2 times sine? 2 sine. What is 3 times 15? 15 sine. Now, can 2 and 15 make 11? No way. 2 and 15 add to be 17. They subtract to be what? 13. No way they're going to make 11. So you see how I know it's not 2 and 3, at least in that order. But we better swap them because the order matters, doesn't it? So let me grab these 2 and put the 3 here and the 2 there and try again. Now the 2 inner make 3 sine and the 2 outer make 10, right? 5 times 2. Right? Remember, we're multiplying. Everything's multiplying. Everything's multiplying, right? These are parentheses. There's times. 3 times sine and 5 times 2 is 10. Now, can 3 and 10 make 11? No way. They make 13. Or if you subtract them, they're 7. No way. They're going to make 11. So now we've tried 3 and 2 in both orders, and we can officially reject 3 and 2. They're not right. Everybody see that? So I know for sure. I've tried the 3 and the 2 in both orders, and it never makes the middle 11. So then I go, what else? Instead of 3 and 2, what else multiplies to be 6? 1 and 6. So I'm going to go 1 and 6. This is the wrong order. I'm going to purposely do it as wrong as I can to show you worst case scenario. So it's actually the other order. But anyway, let's try it. I wrote down 1 and 6. See what I do? I just keep writing down things that multiply to be 6. 2 and 3, 3 and 2, now 1 and 6. But I got to make the middle. The middle is the hard part. How do you get the middle? OI. Outer, the big arc, and inner, little. So the 2 inner, 1 times sine x is 1 sine, or just regular sine. 5 times 6, 30. Can a 1 and a 30 make 11? No way. But swap the order. The order on the back two matters. Does everybody hear me on that? The order on the back two really matters. So let me switch it. Put the 6 here, the 1 there. Let's try it again. Now it's going to work. The 2 inner makes 6 sine. The 2 outer, 5 times 1, makes 5. Now, can 6 and 5 make the middle plus 11? Yes. Both positive. That means both these are positive. There we go. Everybody see that? Getting a little more comfortable with factoring? You can factor. It just takes practice. Checking with these arcs and all that. All right, that's step 2. We factored it. Step 3, what do we do now?
Make their own zeros.
Each one gets their own zero. Take it from there. Now, oh yeah, what about the 2? Well, you can set him to 0 if you want to, but he's not 0. What I mean is 2 equals 0. 5 sine x plus 6 is 0. Well, here, I'm gonna move this up. I need some room. So 2 equals 0. 5 sine x plus 6 is 0. And sine x plus 1 is 0. So that makes sense here. So step 1, step 2, step 3, they each get their own 0. Right? So we have 3 things multiplying, don't we? Do you see the structure that way? We have 2, a parenthesis, and another parenthesis. So those are 3 things multiplying to equal 0. So that means the 2 alone could be 0, or the middle one could be 0, or the back one could be 0. Does everybody see that? But forget about the 2 being 0. 2's not 0. And it doesn't have a variable. See how it doesn't have an x? So it can't vary. It's just always 2. Well, if it's always 2, it ain't 0. If it had an x, or like 2 plus x or something, then I would say, well, yeah, if you got an x, maybe there's a way you can be 0. Yeah, if he was negative 2, and 2 plus negative 2, that'd be 0. Right? Do you see the difference? Do y'all see that? If it has an x, it has a variable. It can vary. It can be different numbers. It could maybe be 0. But if it's just a plain number 2, how can that be 0? Right? Winnie, what do you want to add?
Could you divide 2?
You totally could. I like the way you think. Yeah, if the 2 bugs you, could just divide it off both sides too. Yeah, that's right. Yeah, so yeah, it's disposable. Yeah, so plain numbers without a letter are never going to make anybody 0. They're just 2. Yeah, that's right. All right, so let's just work with the ones that have the letters. Okay, so let's finish those. From there, bump over the 6, so we get 5 sine is negative 6, divide by 5. And then the other one, move the 1 over. Sine x is minus 1. We good to there? All right, unit circle time. It's unit circle time. You ready? Let's go to the unit circle. Where is my unit circle? Okay, there it is. So what am I looking for? Minus 6 fifths. Is that like something you recognize?
No.
No, don't even waste your time. There's nothing on that. There's nowhere the sign is negative 6 fifths. By the way, that's more than 1. That's 1 and a fifth. Remember, sign never goes higher than 1 or lower than negative 1? It's not going to be there. How about this one? Where's sign negative 1? 3 pi over 2. That's our only answer to that whole problem. After all that, 3 pi over 2. It's the only answer.
Would there ever be an answer where it's undefined, or?
No solution? Yeah, it could be. Yeah, if they're all bad. I don't think there's any in the homework that do that. But in general, it's possible, yeah.
Well, it would be possible to test.
It's possible.
Yeah. None of the above.
Is that good? Is this making sense? All right, I better move on. Okay, so here's the real plan. I was just kidding about all that other stuff. No, I was just giving you the short version. The x squared, if you have x squared and x to the first, that's when you do that whole thing, get a 0, factor with the parentheses, and each one equals 0. But if instead you have x squared and no x to the first, that's easier actually. So I want to show you that. Step number 1, let me just say, get x squared alone, do a root and a plus or minus root. So all you got to do is, it's much easier. So that whole three-step process I was giving you, that's true, but you only have to do that when you have x squared and regular x. But if you just have x squared and no regular x, it's easier. That's what we have here. See how we just have a cosine squared and we don't have a regular cosine anywhere? You see the difference I'm talking about? If I had cosine squared and like over here was a 7 cosine normal, you know, then I would go, oh yeah, got to do this whole get a zero factor, blah, 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 three-step process. But if, or if this 1 had a cosine next to it, you know, if there was a regular cosine anywhere, then I would have to do the three-step process. But if you just have x squared and no x to the first power, see how we just have cosine squared and no regular cosine anywhere? These are way easier. You don't have to do all the hard stuff. It's easier. What do? Don't worry about zero, factor, all that. Just get that cosine alone and root it. Just get that cosine squared alone and root it. That'll tear off the square. All right, what's my first step to get that cosine alone? Yeah, add the 1 or just move the 1, whichever way. You're totally right. Positive 1 over there. Next step, divide by the 4. Everybody good to there? So see how I've gotten the x squared alone. That was step 1, get the x squared alone, or the cosine squared alone. And now how do you get rid of that little 2 thing on it? What's the opposite of a 2 power? A root. Getting the hang of that? Roots and 2 powers are opposites, aren't they? They undo one another. So if I go root, and plus or minus over there, the root cancels the square. So cosine x is plus or minus the root of 1/4. And what's that? What's the square root of 1/4? Oh, does everybody see the plus or minus, by the way? You need the plus and minus. You remember that from your algebra days? That's a half, isn't it? Square root of 1/4 is a half, right? Square root of 1 is 1, square root of 4 is 2. The root's gone. Am I going too fast on old rules? How are we doing?
Plus or minus.
Yeah, I'll talk about that. Let me first, square root of 1 is 1, right? Square root of 4 is 2, and then the root's gone. So when you root something, it does its root job and it vanishes. That's why there's no more root anymore. Everybody with me? I rooted the 1, I rooted the 4, gone. The root does his job and leaves, right? Goes home. So plus or minus half. Yeah, why the plus or minus? Because it's true. Think about just numbers for a minute. What if I gave you x squared equals 9? What are the real, all fancy math things aside, what are the real answers? What can I really put in there squared that would be 9?
3 and
3 or negative 3, right? Negative 3 squared is also 9. Negative 3 times negative 3 is also, right? So if I only rooted and didn't put plus or minus, if I just rooted, do you see how I would get less than the whole truth? I would only get the 3. And we know better. It's not just 3. It's also negative 3. So that shows, logically, that you must put plus or minus when you do root, or you're not going to get all the truth, are you? So that's what we have to do. When you put a roof, so I have because everybody forgets that, my job as a math teacher, it's kind of a strange job. I sit at home and think of dorky little sayings to help people remember these things they always forget. I'm like embarrassed about this. But I've already said it, roof on the house, up and down the ladder. I said that? Wendy knows it quite well. When you put a roof on the house, sorry, it's really dorky. If you're going to put a new roof on your house, see you, Wendy, if you're going to put a new roof on your house, you'd have to go up and down the ladder, right? And you think, what does that have to do with this? Well, roof, root, you see my dumb saying? It's like a roof, right? And up and down, plus and minus, up and down, it's best I can do. All right, ever since I started saying it a lot of years ago, more people remembered it on the test, so there we go. So if you're going to put a root on both sides, you got to put plus or minus, or you're missing half the truth. So back over here, when I put a root on both sides, you got to go up and down the ladder and put a roof in the house.
So we're going to have 4 answers.
So we're going to have 4 answers, yeah. So now we go to the unit circle and we look anywhere where cosine is plus a half or minus. There are going to be 4 answers, right? 2 for each one. That's totally right. Yeah, let's go there. Let's go there.
1 in each quadrant.
Yeah, it should be 1 in each quadrant. There's my answer. So plus or minus a half. So remember, it's cosine, sine, cosine, sine. So Cosine, sine, cosine, sine, cosine. There's cosine plus a half. Okay, cosine, sine, cosine, sine, cosine. Where did I miss it? Oh yeah, there it is, minus a half. And cosine, sine, cosine, sine, cosine, sine. There's minus a half. And cosine, there's plus a half. There's 4 answers. All the places cosine is either plus a half or minus a half. See them all there? Pi over 3, 2 pi over 3, 4 pi over 3? Yeah, 4 pi over 3, and 5 pi over 3. 1, 2, 4, and 5 pi over 3. So the answers are 1, 2, 4, and 5 pi over 3. Good? How are we doing? You good? We've done 3 problems in 1 hour. All right. Our average is getting a little faster. 20 minutes per problem. 2 secant squared minus 4 equals 0. That's question number 4. Yeah. So we see x squared. See how this is a secant squared, but no secant to the first power. So just get it alone and root it, right? So just get that secant alone and throw the root on both sides there. So get that secant alone. Move that over. Divide by 2. Good, so I got that secant alone. And then roof on the house, up and down the ladder. So secant is plus or minus root 2. But now flip both sides. Right, so this is cosine is plus or minus 1 over root 2. Is that good? Just flip it. Right, the flip of secant. And we do the same thing to both sides. We flip both sides. You flip secant is cosine. Why do I do that? Because cosine's what, sine and cosine are what's on my unit circle. I need sine or cosine if I'm going to go to the unit circle for help. Right? I got to change everything to sines and cosines when I go to the unit circle, right? Everybody good there so far? I just flipped both sides. Now, one more step. What do you do with 1 over root 2?
Oh, you have to move it.
Can't leave the root in the bottom, right? So remember what you do? Root 2 top and bottom. And you get root 2 over plane 2. We're used to looking for that. Go to the unit circle. You're going to get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. You're going to get all those.
So are you looking for secant or cosecant?
Cosine.
Or cosine?
Cosine in the end.
Why do you switch it?
Because what's on my unit circle? Remember? Only cosines and sines, huh? No secant. So I can't find secant on there. I need sine or cosine. So I had to change it to cosine by flipping it. Yeah, good question, Jose. Good? Is everybody good there? Making sense? So there's my 4 answers. We better move on. There's bigger fish to fry in this section. All right. So, 2 cosine plus 1. Let's see. And 2 sine minus root 3. Yeah. Whoops. Okay. So, see how that one is already partway done? It's like already on step 2. You're done with step 2. Already got a 0, already factored. See how the parentheses are already there? So it's just like almost done. You see that? See how they're pushing you forward? That's the end of step 2. Remember the 3 steps? Get a 0. Done. Factor. Done. Check. Step 3. What's the next step? Each one gets their own 0. Right? Each one gets their own 0. So we just go, okay. So I'm going to go the first one. gets a 0. Or the second one gets a 0.
I thought I had to have a square in it, a square and a square one.
What's
I
that?
thought I had to have an x square and a,
Yeah, that's already done. Does that make sense? It's like they're giving me one that's already 2 steps down. So we're already past the x squared stage, where it's already down to the parentheses, where it's no longer squared.
how do we know it had one to start with?
It isn't really so much that it matters that it had one to start with. It just matters they're giving me a problem already in the second stage. So I can just take it forward from there. Is that good? Is that making sense? So then you just finish each of these up. Since it's already in the parentheses 0 stage. So then just move the 1 over. 2 cosine minus 1 divide by 2. And here move the root 3 over. 2 sine is positive root 3 divided by 2. So we have the cosine is minus 1/2 and the sine is, so you just go to the unit circle. Find out where's the cosine minus 1/2. I don't know. Cosine minus a little bit. That would be 2 pi over 3. And whatever that one is right down there. Is that what it is? 4 pi over 3. And then the other, where's sine square root of 3 over 2? That would be pi over 3. And 2 pi over 3 again, I think, right?
Yeah.
On the unit circle. So really we have a repeat on 2 pi over 3. So our answer,
Do we need to put all 4 answers or can
No.
we put just 3?
yeah, any order, just list the 3 different answers. Any order. There we go. That makes sense on number 5? They gave it to us almost done. They were already down to the parentheses 0 stage. Good there. Questions? Okay, so number 6, cosine plus 2 sine cosine. Equals 0, yeah. Okay. Now, let's kind of stick with the same process. They're going to start changing things up on us a little bit, but not too bad on this one. So as we look at that, how you want to look at it is 2 terms. You want to say, okay, this is one term, this is a second term. Remember the process about step 1, get a 0. Now, I know this one doesn't have x squared. So like Jose was pointing out, it's not really x squared, but I'm going to basically do the same thing. So really that process works in several situations. Yeah, that's part of what's hard about this section, why I call it the harder ones. There isn't just one size fits all. That's what makes sections nice and easy, huh? When there's just one game plan, you do it for 20 problems in a row. What's hard about this section is, especially as we move on now to number 7, number 8, they're all going to be a little different. They're all a little different. So, doing the best I can to tell you kind of a game plan, but there's really not one. They kind of varies. That's what's hard. It's like facing a pitcher that's got all kinds of different pitches. They're going to mix it up on you. It's hard. So, generally, we're going to handle this problem like the other ones. Get a 0. It's already got a 0. Check. Done. Step 2, factor, which means what? Parenthesis, GCF, what's in common, that whole thing. So look at those 2 terms. What's in common?
The cosine x.
The cosine x, huh? See how they both have a cosine x? See that? They both have cosine x. So bring the cosine out and put on the inside whatever works. So cosine times what would go back to cosine? Well, just 1, huh? Cosine times 1 is cosine. Plus cosine times what here would go back to 2 sine cosine?
2 sine x.
2 sine. How we doing? Bernadette. What did you say? You have, Bernadette, you have sine x plus,
Plus 2 sine x cosine x.
like that? So you'll take out sine.
Yeah.
That'll leave 1 plus 2 cosine. Boom, boom. So remember how something would distribute from the outside. Sine times 1 would be sine. Sine times this would go back to that. Right? It's just like a letter. It's just like a letter. It's S times 1 plus 2C. Boom, boom. Go back to 2SC. That makes sense? Everybody good with the factoring? Just, this is C times 1 plus 2S. Right? Goes back to, see how that, cosine times 1 would be cosine. Cosine times 2 sine would be 2 sine cosine. Everybody good with that? It's just like factoring out letters. Sine and cosine is just like a letter. It's like an A or a B or an S or a C or whatever on that. Okay, so now what do we do at this point? Yeah, each one gets their own 0, right? Because if something and two things are timesing to be 0, remember what that means logically? If two things are timesing to be 0, either one could be 0 to make that work. Huh? So the first one could be 0, or the second one could be 0, right? Like that?
And because the cosine has a variable, we have to put it.
Yeah, this time it's got a variable, so we got to do it. Yeah. In fact, he's ready to go to the unit circle. He says, go to the unit circle, find where I'm 0. Let's finish the sine first. Well, we could find him. I'm going to finish sine. So move the 1 over. 2 sine is negative 1, divide by 2. Boom. So go to the unit circle, find where the cosine is 0, find where the sine is negative a half. Cosine is 0 is going to be, where's cosine 0? At pi over 2 and 3 pi over 2. Sine is negative a half at 7 pi over 6 and 11 pi over 6. There's our 4 answers. We good? Can I go on to another one? We all happy? All right, I'm going to move on. There's number 6. So it's basically similar, wasn't it? Just factor, take out what they both have. Each one equals 0. Go to
That structure, like, it's never going to be cosine minus 1. It'll be 1 then minus cosine, like that.
it's like, in other words, it's not cosine squared minus 1.
Yeah.
Yeah, it is this way. Because the cosine moves to the back, it's negative, right? It was positive, jumps to the other side, it's negative.
Yeah, because I did it the other way and I got a whole different.
Yeah, it wouldn't work.
Yeah.
Well, what I should say, to be more clear, any order is fine. You can move the order around, but the signs in the front of them must remain. So as if I want to put the cosine in the front, I could write it that way. See, that minus is still on the cosine? That's the same. But if you write it this way, no. Now he's positive. You've changed his sign. See how that's different? So really, order doesn't matter. Signs in the front matter. Because that's their baby. That's their sign. That goes with them wherever they go. That makes sense? Right, whatever sign is in front of somebody, that's their baby. Take it with you wherever you go, right? It always reminds me of when we had our fifth, we've had 5 children. I never thought I'd have 5 children. They're a lot of fun, especially as they get older. I enjoy them more and more. Anyway, and our 5th little baby, Abigail, she's now 11. But I remember when we had her, by the time you get to the 5th, you feel like, we got this figured out. We know how this works. So my wife and I, we had our process. We come home from the hospital with the new baby. We always go to lunch, just the 2 of us and the new baby, before we go home to the wild home with all the mini children. Little break. Anyway, so I remember going with Abigail. We went to lunch. I picked up my wife from the hospital, come home, stop at some restaurant, jump out of the van, start going to the restaurant. My wife gets out, and she looks at me and goes, so do you want to bring Abby? Or, and I'm like, oh yeah, Abby, and she likes to kid me. I'm a little absent-minded, so I go back and go. Anyway, so you take your baby with you wherever you go, right? So now plus or minus, Abigail's our most, we've lost her 3 times. Anyway, long story short. Anyway, no more stories. All right. Anyway, plus or minus in front, that goes with it wherever it goes. So Clarence, your question is a good one. You can, this would be fine, because that's the same signs, right? Negative is still in front of cosine, negative is still in front of cosine, nothing in front of 1, same as positive. That's the same. This is different, right? So order doesn't matter, signs in front matter. All right, so getting to here, like terms. 2 minus 1, that's just 1. Just combine, just adding numbers there, right? So we got minus 2 cosine squared minus cosine plus 1. Everybody see what happened there? Positive 2 minus 1.
It doesn't matter what order it's
No,
in.
because I'm going to yank all this stuff to the other side anyway. Why? Because I don't want my front one to be a negative. Or I just multiply through by a negative 1, either way. But everybody caught up so far. Everybody see what happened there? 2 and minus 1 made plus 1. They're just plain old numbers. Just put them together. Now, I don't want to factor the way it sits. I mean, you could. There's no rule against it, but it's pretty hard when the front one's negative. You're going to have all kinds of
And you
fits.
don't want the 1 in front? Because.
No, you want squared power. I mean, anything's okay. There's no rules here.
It's just hard.
I'm just saying what's easiest. It's going to be way easier for you to have the squared in the front and to make him positive. So I'm just gonna, you can either jump everybody to the other side, that'll change the sign, or you just multiply through by negative 1. I think I'll just do that. So I'm just gonna multiply through, but does everybody see why I'm doing that? Because the 1 in the front is negative, that's just hard to deal with. So I'm gonna go, look, multiply through by negative 1, negative 1, negative 1. All the way through, what do you get? Positive 2 cosine squared plus cosine minus 1 is 0. It's so small. Here, let me bring it down. So 2 cosine squared plus cosine minus 1 is 0, right? Change. Okay, good.
And the one you used, it was the last number?
What's that?
That's what you used? Why minus 1? Why'd you multiply?
I want to change that front one to positive.
Yeah, but where'd you get the 1 from?
Where did I get this plus 1?
Oh, you using that one?
So
Yeah, I know.
these guys, 2 minus 1 made 1.
Yeah, but then you used that
And then
one
I
to
multiplied
multiply?
all the way through by negative 1. Because you can't just do one part, right? You got to keep the balance, equal treatment. Whatever you do to one part, you got to do to all the parts.
Yeah, but I'm saying if the last number would have been 5, you would have multiplied everything by minus 5?
No. I'm looking at this side, thinking I don't want him negative. So I'm just multiplying by negative 1 to make him positive. That's all. It's a pure coincidence that happens. This could be 17 million.
Okay.
I still multiply by negative 1. Does that make sense? I'm just changing that sign in the front. Okay, so now we're to here because that makes it easier to have that sign in the front. Now you got to factor that. So can you do the 2 parentheses on that and factor that? So factor that with 2 parentheses. I'm going to go to fresh screen. 2 cosine squared. 2 cosine squared plus cosine minus 1. And the 2 parentheses. Remember how, so I'm going to have to go kind of fast on this. So it's FOIL again. Right? First, outer, inner, last. Front times front, make front. Let me give you just a minute on that. Okay, so front times front to make front. Is that good? Okay, and then last times last to make last. What times what makes 1?
1.
1 and 1. 1 times 1 makes 1. And now, what number's in the middle there? Plus 1, right? Plus 1 in the middle. So the 2 inner and the 2 outer. Remember, the middle comes from the OI, outer, inner. The OI stands for outer, outer, inner, inner. Makes 1 cosine and 2 cosine. How can they make plus 1? Remember, no signs yet. No signs till the end. The sign in the middle always goes on the bigger, right? Plus 2 minus 1. Now, the sign here goes straight up. The bottom goes to the back. There we go. Everybody good with that? And then set each one equal to 0. I better move on with this problem. 2 cosine minus 1 is 0. Cosine plus 1 is 0. Jump it over. 2 cosine is 1. Divide by 2. Here, move it over. Where's cosine? So go find, where's cosine of half? That's pi over 3, and
Pi over 3.
isn't it 7 pi? Is it? Oh, 5 pi, yeah. 5 pi. Is that right? 1. 5 pi over 3.
Right?
Is it 5 pi over 3? That could be right. And cosine is -1. That's going to be at pi, right? Those the answers, I think?
Yeah.
There we go. Yeah, every now and then if you have like a 1 or a -1, you only get one answer. But all the rest, I always say it's almost always two answers. Only a couple of weird ones, -1, +1, 0. Sometimes those will have only one answer on the unit circle. Is that good on that? How many have we finished? All right, we better, we got to get through all 16 maybe. We'll see what we're going to do. We only get less than an hour. So, okay. So, what's the problem with this one? What's the trouble with this one? Right off the bat, you see something, you go, oh, that's going to be a problem.
They're not matched.
They're not matched. We got a mixing of sines and cosines. Can't have that. Can't have that. So, what are we going to do? We can't factor right now, can we? Why not? Well, there's nothing they all have in common.
We're going to change that sine squared to...
Yeah, remember those two formulas I gave you. So, remember, if you start with the sine squared plus cosine squared is 1. Remember that? Main formula. Notice you can solve for either one of the... Which one do we always want to replace?
The squared.
The squared one. Is everybody seeing that? I'm going to replace that sine squared right there. You always replace the squared one. Why? Because the replacement formulas are in terms of squares, aren't they? So I'm going to jump this cosine squared over, and sine squared is 1 minus cosine squared. Right? So I'll come right back here, and I'm going to pop in 1 minus cosine squared of x. And then just bring down the -4 cosine, bring down the -4 equals 0. Everybody see that? Everybody see what I did there? See how I replaced sine squared with 1 minus cosine squared? That good? Right?
Will there be a case you can just change both of the tangent or not?
All right, so what do we do now? Well, the usual, meaning gather like terms. All right, so I'm going to say, okay, so 1 minus 4. That's -3. Right, we good there? See how 1 minus 4 made -3? How are we doing? Am I losing you? What should we do now? Yeah, multiply through by negative, because you don't want your front term, your squared term, being negative. That's just hard to factor. So I would multiply through by -1. Everybody seeing that? Just multiply through by -1. So multiply through by -1, -1, -1, -1. And what do we get? Cosine squared plus 4 cosine plus 3 is 0. Everybody good to there? And then factor. So I'm just going to kind of go quick. So cosine, right? I'm thinking FOIL, F-O-I-L, front times front makes front. Front times front makes front. Like that. And then last times last to make 3. What times what makes 3? Yeah, 3 times 1 or 1 times 3. Everybody see what I'm doing there? Remember how to factor? Is that coming back to you a little bit? So front times front to make front. Last times last to make last. 3 times 1 makes 3. Now, how do you know if the middle's right? OI. OI. So the middle comes from the 2 inner, the 2 outer. 3 cosine and 1 cosine. Right? Got a little meter here. 3 cosine and 1 cosine makes the middle 4 cosine. So that's it. Both plus. Both plus makes plus 4. So there's the factorization. Everybody getting the hang of how you factor? Just make sure the FOIL is all right. So, or you can just FOIL it out yourself by hand to see if it's right. Okay. So now set each one to 0. So I'm going to come over here maybe. Take this first one, equal to 0, and then take the second one. Move that over. Where's cosine negative 3? None. There's no places on the unit circle where cosine is negative 3. The highest cosine ever gets is 1. The lowest he ever gets is negative 1. Not going to be negative 3. Where over here, where is cosine negative 1? That is at pi. Pi is the only answer to that question. Good? We okay? I want to get to the bigger fish. All right, so here's number 9. All right, this one is a problem. I'll let you write it down. This one's a big problem. The big problem with this one, you might say, well, he's got a sine cosine mix, that's a problem. Yeah, that's small potatoes now. We got bigger problems than that. The biggest problem this one has, the main thing we need to do something about, is that he's got a 2x and a regular x. See how he's got a 2x and a regular x? We can't be having that. We can't be having a mix. Everybody see that? That needs to be big for you. So let me stop for a second and camp on this. Everybody see. Right here, this is 2x being plugged in, and this is regular x. Maybe parentheses will highlight it a little bit. That's a problem. Those have to be the same. We can't have like it. If they were both 2x, great. If they were both regular x, great. But you can't mix them. You can't mix them. That's a big problem. That's a big deal. So we have to do something about that. So when you have 2x and regular x, use, what are you going to use? Double angle formula. Remember from Thursday? Sine 2x is 2 sine x cosine x. That's the double angle formula from the last section, 3.3. So I'm going to replace this sine 2x right here with 2 sine regular x cosine regular x. How are we doing? Is that okay there? Right? Does everybody see what happened there? See that replacement I made? Now what? Well, now let's do the normal thing where we get a 0 and factor and all that. Why? Because these guys are going to both have a cosine in common and I can take it out. So jump this over. Becomes 2 sine cosine plus root 3 cosine is 0. Does everybody see that? Yeah.
Could you have
I-
divided cosine?
Could I what?
Divide cosine from both sides? Cancel out.
Yeah, you don't. Yeah, good question. Really good question. You don't actually want to divide by anything with a letter in it because you lose the answers that would make that 0. I know that's a confusing thing. Yeah, you never, when you're solving an algebra, you never want to divide by anything that has the x in it. Yeah, that's a great question. See, let me give you a simple example. If you had x squared equals x, now isn't it true that 0 is one of the, well, let's just look at that for a minute. What could I plug in for x that would make that simple equation true? 0 and 1. Does everybody see that? If x is 0, 0 squared does equal 0. And if x is 1, 1 squared does equal 1. Nothing else works. You might think negative 1 works, but it doesn't. Negative 1 squared is not equal to negative 1. And no other numbers work. But 0 squared is equal to 0, and 1 squared is equal to 1. So what? So my point is, go back to the original question. X squared equals x. The real and true answers are both 0 and 1. They both make it true, don't they? But if I do the technique of dividing both sides by x, I will lose my 0 answer. See what happens there? What is x squared over x? Plain x. What is x over x? 1. I only get the 1. Where'd the 0 go? Bye-bye, because that would make the bottom 0. So it's not going to, you're going to mute it. You're going to close its mouth and not allow it to tell you the 0 answer, because that would mean dividing by 0. I know it's a higher level math kind of thinking, confusing thing. Long story short, don't ever divide by anything with a letter in it. Or where that answer is 0, you will close its mouth. It won't tell you about it anymore because it doesn't want to make division by 0, because you can't divide by 0. Probably a big story. For now, you get a little bit higher in math, you can talk more about it, but just never divide by anything with the letter in it. Never do that. So that's a good question. Never divide.
Does it matter if the formula is actually datum, choose sign?
X, whatever the letters, doesn't matter. Yeah, good question. Doesn't matter. All right, so now we're to here. And can you finish it? What do these both have? Cosine. Take it out. Parenthesis. Good to there. H1 equals 0. So cosine alone is 0. 2 sine plus root 3 is 0. Am I going too fast, right? So you factor, and then each one gets their own 0. Then you finish it from there. So I'm going to jump this over. Minus root 3 divided by 2. Minus root 3 over 2. So just go to the unit circle. Where's cosine 0? At pi over 2 and 3 pi over 2 cosine is 0. Where's sine negative root 3 over 2? That is, I think, is it 5 pi over 3? And just shy of that. Is it 4 pi over 3? I think that's, oops. Come on. Isn't it 4 pi over 3 and 5 pi over 3, right? Are those right?
That's what I got.
Is that right? Okay, good. So we're done. We good there? So everybody see the trick on that one.
Wait.
Sine 2x. Sine 2x.
Oh.
Became 2 sine cosine of regular x. Everybody see that? So you got to watch. So when you see a 2x and a regular x, you got to use that formula. Okay.
How did you?
Yeah, I factored it out. They both have one. So they both have cosine. So that's factoring. So they both have cosine. So you know what that's like. I know some other people asked me about that too. So let me show one more time. So for factoring, are y'all remembering factoring a little bit? So just pretend that was S and C. Sine and cosine is S and C, right? Plus root 3C. So maybe it'll be easier to see if I just change it to S's and C's. Right? S, C, C. Right? See how I rewrote it here? If you were looking at this and this, what do they both have the same? What do they both have? A C, huh? So you could put it in the front. This is called factoring. When you say, hey, what multiplied to become this? That's what you're basically doing. 2S, right? Because C times 2S, we go back to 2SC, and root 3. Everybody see that? That's what I basically just did. Took out that C in common. We good? All right. So sine 2x. Oh, we need this new one here. So number 10 here. So cosine 2x. Let me rewrite it. Cosine 2x plus 7 cosine plus 4. Plus 7 cosine plus 4 equals 0. Okay. So, right, yeah. Okay. Same thing there. Now, the cosine 2x. See how we have the same issue again? We have a 2x and a regular x. But this time it's a cosine. So 2x and regular x. We're going to have to use cosine squared. Cosine 2x. Cosine squared minus sine squared. I don't want to use that. There's 3 different options. I didn't give you all those options back in 3.3. I wanted to keep it as simple as we could at that point. But there's different options for cosine 2x. Let me make sure I have those right. Cosine squared minus sine squared. 2 cosine, right. Yeah, so there's 3 different things you could use for cosine 2x. They're all true. You can have a lot in your 3x5 card for this test tomorrow. This test is tomorrow. Wow. Yeah. All right. Never a dull moment in the summer, huh? So, we good to hear? All is well so far? So, this piece right here, I'm going to replace it with one of those. Which one? This one. Because that one is pure cosine, and that's what I want. I don't want to bring in either of the other two have sine in them. I don't want to mix in sine with cosine. Everybody see that? See why I'm choosing that one? For other problems, I might choose differently. It just depends on what I have on the scene at the moment. Everybody see the deal? So I'm going to replace cosine 2x with 2 cosine squared minus 1. We good? Okay. And now, right, so see how we got it all cosine by doing that maneuver? And all regular x, not 2x? You see that? See how we changed it? So then, I'm just going to do the usual. Minus 1 plus 4 is plus 3. I'm just going to go quick here. I'll let you look back at this later. But I'm getting there. We're not going to get to the other, so I don't move it. So 3. How are we going to get that 3? Remember, we're thinking FOIL here, right? F-O-I-L. OIL. The 3's got to be here and the 1 here, plus and plus, because the 2 inner will make 1 cosine, the 2 outer will make 6 cosine, both plus will make 7 in the middle. So there's the right way to factor it. And then so each one gets its own 0. So the first one gets a 0. Second gets a 0. Jump it over. Divide by 2. Jump it over. None. There's no answers out of that one. The other one, I don't know what they are. Where's cosine negative a half? What is it? 2 pi over 3 and 5 pi over 3. 4 pi over 3. 2 and 4 pi over 3, right? So it's 2 pi over 3 and 4 pi over 3 come from the other one. Is that okay? Everybody see that there? So it's the same kind of thing. We're replacing cosine 2x. Any questions I can answer on that one? Logic puzzles, not physical puzzles. All right. Sine, cosine equals 0. Sine, cosine. That's like a weird question. They're mixing sine and cosine. They're mixing sine and cosine. That's a problem. So here, number 11, sine, cosine equals 0. So number 11, sine x, cosine. Because they're mixing sine and cosine, I'm going to use the double angle I gave you a minute ago. Sine 2x is 2 sine x cosine x. Yeah. Do you see that? I'm going to use that one because I want to get it to just sine. I don't want a mix of sine and cosine. Is that making sense? Everybody see that? I'm looking at this question, and I have no way of solving it as it stands. They're mixing sine. They're mixing sine and cosine. Now you might think, well, Mr. we did that before. Yeah, when they all had something in common, like back over here. Well, not there. It's been a while. Anyway, I don't got time. Oh, what did I just hit? Something dumb. All right. Anyway, yeah. If there was a couple of terms, but anyway, we can't have a mix the way it stands. We can't have a mix on this one. So sine and cosine, we can't have a mix like that. But that's all there is. That's all there is sine and cosine. There's no other term. Right? You know what I mean? If there was sine, remember I better describe what I'm talking about. If there was a sine cosine, and then there was also a -7 cosine. Yeah, I'd be okay with that, because then I say, oh, they both have a cosine, take it out. I would do sine -7, and I could do it, right? If there was 2 terms and they both had a cosine. That's okay. It's okay to have a mix. If there's a couple of terms and they have it in common, you could factor it. But when they don't have that, when they just have sine, cosine, 0, I got to do something about that. Benjamin.
Since they're factors, can we set them equal to 0 right now, individually?
That's what I was thinking.
Oh, yeah.
Sine x equals 0, cosine equals 0.
Yeah. Yeah, man, we can just do that. We don't need to do all this fancy stuff. That's a good idea, Benjamin. Yeah. Yeah.
It's ones where it's makes you think it's harder than it is.
Yeah. That's what made me think. Yeah. Yeah, forget about all that.
I was wondering how you were going to make the...
Yeah, they're timesed. Yeah, they're times to equal 0. So either one could be 0, right? That's my old logic. If 2 things are times, it's going to be 0. First one could be 0, the second one could be 0, right? If either one of those is 0, then they're going to times to be 0, right? Yeah, that's great. So just go to the unit circle. That's great. Benjamin, you saved the day for sure. Because we got some other hard ones. We'll have more time to get onto them now. Where's the sine 0? Sine is 0 at 0 and pi.
0, not 2 pi.
Right. Yeah, they don't want you to say 2 pi. They want you to say 0, although it's the same place. Where's the cosine 0? Pi over 2 and 3 pi over 2. Done. Yeah, nice. I wonder, though, is anybody else on number 11 now?
Yeah.
They give you a number that's not 0?
Yeah.
All right, I better show you that way. All right, there's a harder version. Benjamin, you made a good observation, but we do have to do the harder version. What do you have? Like, Manveer, what do you have? Yeah, okay, I better show you a different game plan, too. So what if they don't give you 0? That was a great idea for 0. But what if they give you root 3 over 4? You're going to have to use that thing I'm talking about. Yeah, so let me give you a different, harder number 11. I happen to get an easy one. Right? Okay, so, yeah, what do? We're going to have to make this, we're going to have to use this right here. Now, this is tricky. This is like what you start to, this is edging into higher math here, pre-calc and calc. What we do a lot in those higher classes is we do some kind of substitution, but we are forced to tinker with our substitution before we do it. So it's good to get comfortable, to begin to get comfortable. I want to replace sine cosine. Anywhere I see sine cosine, I want to replace it. Well, look up there. Well, I don't have sine cosine. I have 2 sine cosine. Right, so make it sine cosine. Meaning, go up here and divide both sides by 2. Boom, then it's sine cosine. So sine cosine is sine 2x over 2. Right? Everybody see that? Sine cosine is sine 2x over 2. Right? I just took the identity that they gave me out of the book, and I said, well, I don't want 2. I have to replace sine cosine. So I have to first solve for sine cosine, and then pop it in. Everybody see that? I have to take the identity, get rid of that 2, because I don't have 2 sine cosine. I got regular sine cosine. So I got to divide by that 2. So I get regular sine cosine is sine 2x over 2. Can I just cancel these 2's? No. That's in the toaster. That 2x, that's not multiplication. That's not sine times 2x. It's sine of 2x. And 2x is plugged into the toaster. It's into the sine function. It's in the sine function. It's not outside for canceling. So we can't do that. In fact, why don't we make it easier by, instead of dividing by 2, be easier just to put the half in the front. That's the same thing, right? A half is the same as dividing by 2. Good? So, what does this mean then? Wherever I see sine cosine, I'm free to replace it with half sine 2x. So right here, this will be replaced with half sine 2x. Everybody see that? Right? Sine cosine is a half sine 2x. Okay. Now, is that good? That is good. Because now it's just one sine. I can solve it now. Let's get that sine. What do I do to get that sine alone? Got to get rid of that half. How do I get rid of that half?
Multiply both sides by 2.
Multiply both sides by 2 over 1, or just 2. Boom. Sine 2x equals 2 goes into 4 2 times. Root 3 over 2. Bring it up here. Everybody get to there? Is that too fast? Am I losing you? Only got half an hour left. Do as many of these as we can. So sine 2x is root 3 over 2. We good to there? Now, because that's a double angle, it's not a regular x, we got to do a bunch of stuff. I don't know if that's clear. Do you remember that from Thursday? That's why I broke it into easier and harder. Remember when you had the 2x or the whatever? You had to go the plus 2 in pi. And you got to do the n equals 0, n equals 1, n equals... Remember that? You got to do that whole thing. That I hope you mastered in last night's homework. That's why in math you always want to keep up. Because you're always going to build on what you just did. And if you didn't do it, you're in trouble when you try to build on it. Right? You always want to keep up in a math class. Because we build on what we just did. So I'm going to do what we just did at this point. We saw in the easier ones that whenever you have like a 2x or something like that, you have to do you can't just do the regular. So let me go to a fresh screen. We're still finishing number 11. Sine of 2x is root 3 over 2, right? So now you can go to the unit circle, look for root 3 over 2. What do you see for root 3 over 2? If you go there, where is the sign root 3 over 2? Let me go to the unit circle with y'all. What it is. So cosine sine, so cosine sine right there, root 3 over 2. And cosine sine right there, 2 pi over 3. So pi over 3 and 2 pi over 3. Sine is root 3 over 2. You with me? I'm just looking for where is sine root 3 over 2. So pi over 3 and 2 pi over 3. So I write pi over 3 and 2 pi over 3. Now, if this was just an x instead of a 2x, life would be so much easier. We would be done. We would say done. Pi over 3, 2 pi over 3. Type them in. We're done. But that's a 2x. Remember what we did when there's a 2x? This isn't x equals, it's 2x equals, first off. And you have to do the plus 2 in pi thing. Plus 2 in pi, or 2 pi in, however you want to say that. To both of them. And let n be 0 and n be 1. N be 0 and n be 1. You have to go up to 1 shy of the number. Did you understand that from last night's homework? So in other words, let me make sure this is clear. If you had 3x, you would have to do n equals 0, n equals 1, and n equals 2. You go up 1 less than the number you have next to the x. Does that make sense? Everybody making sense of that? When you have the multiply, like a 3x, see we have a 2x here, then you have to do the plus 2 in pi, and then you have to do plug in n up to 1 less than whatever the number in front of x was. See? So if I had 7x, I'd have to do the plus 2 in pi and do n equals 0, 1, 2, 3, 4, 5, and 6. 1 less than 7. Everybody see that? Because that gives you 7 answers. How about that? 0 to 6 is 7 answers for 7x. For 2x, there's going to be 2 answers, 0 and 1 for each. So that's what we did in last night's homework. We have to do that here. So, all right. Let's do it. So plug in 0. Plug in 0, that's just gone. You just get pi over 3. Plug in 0 here, you just get 2 pi over 3. Plug in 1, you get pi over 3 plus 2 times 1 pi, which is pi over 3 plus 2 pi. Good here? So I plugged in 0, gone, just pi over 3. Plug in 1, pi over 3 plus 2 pi. How do you add those? Wait a minute, am I doing this right? No. What did I forget to do? You know how I knew something was wrong? This is more than 2 pi. 2 pi plus something? So what did I do wrong?
Oh, you have to divide by 2.
Forgot to divide by the 2. Right, you got to get x alone first. Let me go back. I forgot one step. See, they trick even me. These are hard ones. So go back, divide by the 2. You got to get x alone first, huh? Divide by the 2, which means multiply and divide the 2 like that. Right, Gonzo? Am I going too fast? Remember this? This was all last night's homework. Divide by the 2, you get x alone. It's pi over 6 plus n pi. Same thing here. Divide by 2. Do you see how do you divide a fraction? You got to divide everybody by 2. How do you divide a fraction by 2? You multiply the denominator by 2. That divides it by 2, doesn't it? Everybody see that? That's how you divide. Remember we did this last time. 2's go in, so x is pi over 3 plus n pi. Okay, so now we let n be 0, and you just get pi over 6. And n be 1, and you get pi over 6 plus 1 pi. All right, just let n be 1. How do I add these? Common denom. This is over 1 right now. Multiply top and bottom by 6. And you're going to get 7 pi over 6. And then on the other side, let n be 0. You're going to get pi over 3. and let n be 1, and you're going to get pi over 3 plus 1 times pi. Put this over 1, multiply top and bottom by 3. And you get 4 pi over 3. Done. Those are the 4 answers. How we doing? That took up a lot of time, huh? We got 20 minutes left. I want to get through a couple more. We got 5 more. Don't forget them all. Does everybody see what happened there? Everybody see that? So when do you have to do this whole rigmarole? Whenever you got something other than plain x, you got like 2x or 3x or 4x. That's when you have to do this. You have to go the plus 2 in pi, solve for x, divide through by 2 or 3 or 4 or whatever, and then plug in n equals 0, n equals 1, n equals 2, all the way up to till you have the same number of answers, till you're 1 less than the number. How about that? Right? I had 2x, I have to do 0 and 1. If I had 7x, I'd do 0 through 6. Right? There's my 4 answers. So Benjamin, I thought you saved the day with the easy solution, but it was just for the 0 case. That was a nice way to go for 0.
So pi over 6.
Hopefully that'll be the 0 plus somehow.
All right, we've got to move on. So sine x is negative. So number 13. Right, negative 3/4, yeah. Okay, so that's not in our unit circle. Minus 3/4 is not. So this is a calculator problem. And see, how do we know also? They say round to 4 decimal places. So that means we're using our calculator, huh? So this is a calculator problem. So the first step, how do we solve for x here?
Inverse.
Sine inverse. Right, sine inverse cancel. That gets x alone. Sine inverse of minus 3/4. So go ahead and do that. Make sure you're in radian mode. Got to be in radian mode. Make sure you use the negative button, not the subtraction. I'm getting negative 0.84806. I'll use 5 decimal places, 1 more than I need in the end, so that my final answer is accurate to 4. Everybody good to there? Now, how do I get the other answer? So this is, first off, let's determine which quadrant. All students take calculus. So this original sign is negative. Which quadrants, we're looking for 2 answers, 2 quadrants, is sign negative? 3 and 4. Quadrants 3 and 4, right? Because sine, all are positive in the first, and sine is positive in the second. So it's quadrants 3 and 4. Okay, so we got that determined, 3 and 4. So that means here and here. Same reference, off the x, the same, right? See, I put those both off the x. I didn't use the y, did I? The reference angles are the same. Same off the x-axis. Why? Why is it all about the x? Because that's where 0 starts. They made this whole system up starting with 0 on the x-axis. They made it up. They could have started with 0 straight up, and then everything would have been off the y. But they put 0, they put our clock starting right at x, instead of like a real clock, which starts straight up. Right? So they put x to be 0, so everything's off x. So now, this negative 0.84 angle, where is it? Which one? My calculator is giving me one of the answers. Which one is my calculator giving me? Do you remember the restrictions on sine inverse and tangent inverse? We've had a lot of information at this point, haven't we? Do you remember? Sine inverse is and tan are always these 2 quadrants. Remember that? And cosine inverse does these 2.
Oh, right.
Remember that?
So it's this one.
So sine inverse, so they all use the first quadrant and one other quadrant, don't they? See how they all use the first quadrant? All 3, sine, cosine, tangent, inverse, all use the first quadrant for positive answers and one other for their negative. Either second quadrant, cosine inverse goes there for his negative, and fourth is where sine inverse and tangent inverse go for their negatives. So this negative, when I say that, I mean that's what the calculator will tell you. So when you hit the buttons on the calculator, It will only tell you answers for cosine inverse first or second, sine inverse tangent inverse first and fourth. That's all it'll tell you. So that means this answer must be a fourth quadrant answer. This is down 0.84806. That must be fourth quadrant. Down, negative angle, right? Right, everybody tracking with me? So, get that out of the way. So, therefore, we've got to find the one in the third quadrant, which is also down 0.84806.
But if we're starting from 0, it'll be.
Yeah, so now how do you name it in the third quadrant? Everybody with me? Everybody, am I losing everybody? I know this is confusing stuff. So is everybody getting the idea? So first off, you find where the one your calculator is giving you is, fourth quadrant. And then you draw the same thing in the other quadrant where the same sign exists for your trig function. In this case, sine is negative also in the third. So we're going to the third. Okay. So if this is down 0.846 and this is down 0.84806, how do you name it from 0 though? Right? Starting from here all the way to there. That's how you actually name an angle, starting from 0. Right? You don't start over here. You start at 0. So what must this be? If I tell you I'm right here, I'm 0.84806 below. So how far is it from here all the way to there?
It's
Pi
plus
that, you see. It's pi. The other must be pi plus the 0.84806. Does everybody see that? You see how we're turning more or turning back? So just think about turning further or turning back. So in the last problem, from 0, I turned all the way to pi and then backed up my turn to here, because this is where I wanted to end up shy of pi, shy of 180, less than 180, right? I wanted to end up in the second quadrant. So I rotated all the way to pi and then backed up. So it was pi minus the reference angle, wasn't it? To get the second quadrant answer. Do you see that? But now it's rotate all the way to pi and add some more. You think, yeah, but you said this is negative. Whatever. It's a distance. It's whatever you need to do.
So why is the first one negative?
Because it's down.
Oh, because of the.
From 0. So from 0, positive would be up here.
But we only go negative in that one quadrant.
Yeah, right. That's how they want to see it. Instead of doing like all the way around, yeah, they want us to go negative in that quadrant for sine inverse. Clarence?
So it's possible for like, let's just say example, like, let's say you're, because I got cosine -4 over 7, but like both my answers came out positive when I did the whole, minus pi and add addition to pi.
So you hit the buttons on your calculator.
Yeah, I did it all a different way because it was mine was cosine.
Yeah,
sine.
right.
But
Yeah.
I mean, both my answers came out positive.
They would for cosine.
Okay, make sure.
Yep, that's right.
And for that problem, like you just did, to find the second angle,
For this problem,
yeah, why don't you go underneath?
that would be negative.
You don't want that.
Yeah, we don't want negative. Yeah, we don't want negative. So let's give that answer. Oh. Yeah. Okay, yeah, we're almost there. And I'll explain. You remind me of something. Okay, let's get the second answer, and then I got to fix the first answer. It's not actually right. At least they don't want you to say it that way. It's the right place. But was there enough wrinkles already? All right. So what do we get? 3.9897. It actually rounds to be. So that's the other one from 0. Now.
So do they want the other one in a positive?
They do. See how I said this is, and my calculator told me it's negative 0.84806. It is, but that ain't how they want you to say it. Well, how do I know that? Well, look, what do they say? Give it to me between 0 and 2 pi. I don't see any negatives in there.
So we're going to.
That's between 0 and positive. They don't want negative. So you want to say the same place, which is negative, right? So it'd be like me saying, all right, I'm gonna start here, and I'm gonna turn towards the door. I could turn that way, turn to my right, some amount, whatever that is, or I could turn the other way. I still end up facing towards the door. In the end, I'm still rotated until I face the door, right? So we're saying there's two ways to face this direction. You could rotate down, that's what my calculator told me, negative, or you could start from 0 and rotate all the way to there. That's the same ending place. How do you do that? You go all the way to 2 pi and you back up. So they don't want you to say it this way. They want you to say 2 pi minus 0.84806. That'll be the positive version of the same thing.
So 5.4351.
And that's 5.4351. There's the two answers. Let's go type min. What? Well, that's pretty confusing, huh?
Yeah.
So you see what's going on here. The problem is the calculator's talking in one kind of language and the question's asking us in a different language. That's the hardship on this problem, is communicating between those two languages. The calculator gives us a negative angle, but they said I only want 0 to 2 pi. So you find that same place by 2 pi back up and then pi add that amount. Just remember, whatever your calculator tells you is a reference angle off the x-axis. And then just find it in the two quadrants you need on that. Yeah, I don't know.